Alright ladies, I'm just gonna do some recap on work, energy and power, and then I'll head into the worksheet that I gave you to do, the little quiz, and then I'll work a few more questions, just to clarify any misconceptions that might be there. I'm seeing that some persons did really well on the quiz, but there are some persons who did poorly as well. There may be some misconceptions there. So this is going to be a recorded class, and then the next class that we have on Thursday will be our first Zoom class. All right. So the first thing we need to understand is what energy is. All right. All right. So energy is defined in physics as just the ability to do work. All right. And if you notice, the definition pretty much includes work. Now, there are different forms of energy. We know there is light energy, there is chemical energy, there is nuclear energy, there is kinetic energy, potential energy, which we'll look at those two specifically. So there are a lot of different forms of energy, right? Thermal energy we'll also look at in fourth form. So all these different energies give you the ability to do work, right? And work, right, we defined, right, as when a force moves an object or a body or a system a particular amount of distance, right? So work we define as force multiplied by distance, right? So that's what work is, right? Both of these are measured in joules. That's the SI unit. So the SI unit for work and energy is the joule. All right, this part didn't write properly. All right, so the SI unit for work and energy is the joule. So they are both measured in joule. All right. Now, in terms of work, which we'll look at specifically right now. All right, let me just clear the board. It's a very small space I'm working with. In terms of work, since work is equal to force times distance, it can also be measured in Newton meters. All right, so you can also write your answer in Newton meters. It's the same thing. All right, now sometimes when you lift an object, you do work on the object. If you lift an object, you have to do work against gravity, right? So sometimes work is done against gravity, right? When work is done against the gravity, right, then the force is the weight of the object. And if you remember from the topic that we did in third form, weight is equal to mass times g, right? So weight is equal to mass times g, and then we multiply that by the distance that you lifted, which is the same thing as height, right? So this is if we're finding the work done against gravity. All right, so let me see if I can use a different color here. So this right here is the work done against gravity. All right, so whenever a question asks you what is the work done against gravity or what is the work done in lifting an object, then it is W equals mg, which is the weight or the force that you're using to lift, because you have to lift pretty much the same force that is the weight of the object, and then h will be your distance or your height above ground. Right, we'll see some examples, so don't worry about it. Right, so work is equal to force times distance, right? The force that you apply multiplied by the distance that the object moves by. If it's work against gravity, meaning lifting an object vertically up in the air, right, then the force is the weight of the body, which is mass times g, which you know that g is approximately 10 meters per second squared, right, or 10 newtons per kilogram. But at this level, we'll mostly use it as 10 meters per second squared, right? And then multiplied by h, which is our distance. So because our distance is now a vertical distance, we just call it height, right? So that's work, and we've looked at energy. So both are measured in joules. Work can be done on an object horizontally, right, we won't look at an angle. We will just look at vertically or horizontally. All right, so you don't have to worry about any angles at this level until you get to Cape, and that's if you do physics at the Cape level. All right, so then we come in with another concept, and that other concept is power. All right. So power is the rate at which work is done. So it is work divided by time, or energy divided by time, right? So power is the work at which energy is done, the work at which energy is transferred, right? Or the work at which energy is produced, right? So it's work divided by time or energy divided by time. So the SI unit of work then is, the unit for work then is joule for energy or work divided by second, or joules per second, and that is equivalent to the watt. Right? So 1 watt is equivalent to 1 joule per second, and we can also write it like this. Right? I didn't write properly. Joule per second. So JS minus 1. Right? So 1 joule per second is equivalent to 1 watt, and that is the unit for power, watts. All right, let's erase this and show you some things here. So if we know then that the unit for power is watt, we can know some other things. For example, if a light bulb's power is stated as 100 watts, so let's say your light bulb has a power rating of 100 watts. That is equivalent to it producing 100 joules of energy every second. That's what that means. And we know a light bulb produces light and thermal energy, right? Let's say, for example, you have a fan, and the power rating for the fan is 50 watts. That means that it creates 50 joules of energy every second, right? And the energy that a fan produces is kinetic energy, so it produces 50 joules of kinetic energy per second. So just remember that watts means energy or work done per second. All right, so let's see if we can get into the worksheet that was done. I think the answers were shown to you after you've completed it, but just to make sure that everybody is on the same page, I'll go through it. All right, here we go. Boom. All right, so it says, what is power? So power is the rate at which work is done. So that answer will be the last answer there. All right, and then next one says, which of the following best describes the concept of work? All right, so work is a force moving an object through a distance. Remember, work is equal to force times distance. What is the unit of work? We know it's the joule. All right, the same for the unit of energy. 1 watt equals 1 joule per second. We just did that. All right, well, I don't know which number this is, but this one now, it says how much power is needed to complete 150 joules of work in 40 seconds. So what we would do is we would say power equals energy or work, anyone, over time, and it was 150 divided by 40, right? So that would equal to 3.75 watts, right? And that was the answer there, right? 3.75 watts. So that would be A. The next one says, a weightlifter holds an 800 Newton barbell over his head at a height of 6 meters. How much work does the weightlifter do on the barbell? All right, let's do that one. I forgot the numbers. So it's an 800 Newton barbell, 6 meters. So work. So because they didn't give us the mass, we don't need to find the weight. They already gave us. Alright, so work is equal to force times distance. So it's 800 newtons multiplied by 6 meters. Right? So this would be 8 times 6 is 48 joules. Right? That should be it. Right? So the answer would be C, or 4,800 joules. Right, next up, a mover pushes 1700 Newton piano up a 4-meter ramp. How much work is done? Alright, 1700, 4 meter. Alright, so it is the same concept. So we'll just erase this part. Remember to pause the video whenever you need to, so you can record your answers. So it's 1700 multiplied by 4. Right, which I believe the answer is 6,800, and it will be joules again. Right, next up it says how much work is done when an engine generates 400 watts of power in 25 seconds. Right, so we're finding something different here. Let's just erase all of this. So this time we are given power and time, and we're asked to find work. So remember, power is equal to work divided by time. Right? So therefore, if we transpose to make work the subject, then work is equal to power multiplied by time. Right? So that means that our work is equal to, what will be doing? Oh, we're finding time. No, we're finding work. 400 times, yep, there we go. Alright, so it'll be 400 times 25. Alright, which would give us 10,000 joules. Right? So that would be our answer for that one. Alright, so that is the quiz. That's everything. So correct what you need to correct. Right, and you know, much better luck next time for those of us who needed some improvement, and well done those of us who got very good grades. I think the highest was 7 out of 8. I think there were 8 questions. Yeah. All right, so now I have some example questions that we need to work through. Let me see if I can find them. Okay, here we go. Alright, so the first one here says calculate the work done by a 47 Newton force pushing a pencil 0.26 meters. Alright, so let me just get my calculator. Okay, pardon the noise. Alright, so calculator. Alright, so I have it open here. Okay, so we're finding work and we're given force and distance. Alright, so that should be easy. Work is equal to force times distance, and it's 47 newtons multiplied by 0.26 meters. Alright, so that gives us 47 times 0.26. Alright, it will be 12.22 joules. Easy peasy. Alright, next one says calculate the work done by a 47 Newton force pushing, right, a 0.025 kilogram pencil 0.25 meters against a force of 23 newtons. So this one is a little bit more tricky, right? So let's break it down to make sure that we understand what's going on. So we're still finding work. We know that work is force times distance, but now we're giving a little bit more information to work with, right? So we should be able to figure this out. All over the place. Yeah, here we go. All right, so we're given a mass. So because we're given a mass, we know that we have to convert that. Well, no, we won't have to convert it because we actually have the force here that we're working with. All right, so the force that we're working with is 47 newton. We're not lifting it. All right, so if we were lifting it, we would need to convert the mass to kilogram, to newton, sorry, to weight. Because we're not lifting it, we don't need to worry about that. We're already given a force that is used to push. The only other force that we're concerned with is the force that we're pushing against, right? So the net force then is what we need to calculate first. So the net force is the force that we're pushing with minus the force that we're pushing against, right? So that leaves us with a force of 24 newtons. So this is our net force, right? And then now it's set, we know that work is equal to force times distance, right? So 24 newtons multiplied by a distance of 0.25 meters, right? So 24 times 0.25 gives me 6. And we know that's joules, 6 joules, right? Sorry about the space there. Let me just erase it and put it somewhere else in a different color. Right, so that's 6 joules. Alright, so again, just to recap, we are only concerned with the mass of the object if it is being lifted up, right? Because it is not being lifted up, we are not concerned with it, right? We are only concerned with the other force that they're saying that we're working against. So we are pushing with a force of 47 newtons, but we are working against a force of 23 newtons. So the net force, or the overall force, would be 47 newtons forward minus the 23 newtons backward, right? So if you need an illustration of that, let me just erase this top part here, just to, for those of us who are pictorial learners. If this is our object, right, then our forces would look like this. So we are pushing with a force of 47 newtons, right, and we're going against a force of 23 newtons, right? So the overall force would be 24 newtons forward, right? So we subtract the 47 newtons from the 23 newtons, right? And we get 24 newtons going forward, right? So that would be that. Okay, let me remember, pause the video whenever you need to, so you can write down what's going on, because I won't pause no one say, hey, write down what you're writing down. I'm just gonna erase what's going on here now. Okay. Okay, moving on in the news. I'm going to skip down to one that has a little bit something differently. Okay, so here we go. Number 5. So number 5 says, how much work is it to lift a 20 kilogram sack of potatoes vertically 6.5 meters? So now we're lifting something, right? So now we need to make sure that we use this formula. Work is equal to mg for the weight multiplied by the height that we're lifting it, right? So the mass is given as 20 kilograms and it's lifting 6.5 meters. So 20 kilograms, G is 10, and it's lifting 6.5 meters. Alright, so it'll be 20 times 10 times 2.5. 6.5, my bad. So that will be 1300 joules. Alright, so that's the only time we're concerned with the mass of the object, when we're lifting the object against gravity. So this time we're finding the work done against gravity. So always remember that, always bear that in mind. We're only concerned about the mass when the object is being lifted, not push and pull across the ground. We're not concerned with it at that time. Alright, so moving on the list. Right, number 6, it says if a motor does 520 joules of work to move a toy car 260 meters, what force does it exert? My bad. Alright, let me erase this. So now we're given the work, we're given the distance, and we're asked to find the force. Right, so work is equal to force times distance. So if we want to find force, then our force is equal to work divided by distance. Right? So force is equal to 520 joules divided by 260 meters. Right? I believe that works out to 2 newtons. Right, so that would be our answer, 2 newtons. Alright, so this time we're finding force. Ladies, please make sure that you can transpose formulas to make something else a subject. We're going to do this a lot in physics. Alright, so you have to be on top of your math game. Alright, now I need to find one to work with power, so we can get a couple practices on power before we close off this lesson. Pop it up. Okay. I don't see any on power here. Don't see any on power here. Alright. So let's say we go back to number 5. Right, number 5 says how much work is done to lift a 20 kilogram sack of potatoes vertically 6.5 meters. Right, so we worked out that work to be 1300 joules. What if the question now says that it took 30 seconds to perform this task? What is the average power exerted? Right, so the work done that we calculated for number 5 was 1300 joules. What if the question now says that it took 30 seconds to complete this, right? And we need to find the power. Power is just equal to work divided by time. So it'll be 1300 over 30 seconds. If your time is in minutes, you need to convert it to seconds, right? So 1300 divided by 30 will be our power, and we get 43.33. Right, and we know that's watts. Alright, so that's pretty much it that I want to review with you to make sure that you have a better understanding. If you have any questions, please make sure that you post them in the classroom, so you know we can make sure that we're good. We're going to focus on kinetic and potential energy after this, right? So I'll find a video and post that also for you to familiarize yourself with it before we actually do the lesson on, I think, a Thursday we have class. Yeah, Thursday. All right, cheerio.